Hi dear students, welcome to Math Solutions by Pani. In this video, yesterday we completed in exercise 5a, the first bit completed. Now we enter into the second bit. Is the function f defined by f of x if x is less than or equal to 1, 5 if x is greater than 1, continuous at x is equal to 0, at x is equal to 1, at x is equal to 2. So we need to verify at these 3 points. First, continuity at x is equal to 0 I am going to verify. Continuity at x is equal to 0. So that means x is equal to 0, 0 is less than 1 only, no? So whenever 0 is less than 1, x is less than 1, which function you have to consider? X. So f of x is equal to x you have to consider. So f of 0 calculate. F of 0 is 0. Equation number 1. Now limit x tends to 0 f of x. Limit x tends to 0 f of 0. So f of 0 means what? 0 only, no, dear students. So from 1 and 2, limit x tends to 0 f of x is equal to f of 0. Therefore, f is continuous. F is continuous at x is equal to 0. Okay. Now, this is the first case completed in this. Now, Roman letter 2 we are taking. What is the Roman letter 2? We are the case. Please like and share, dear students. It reaches to more students. Checking the continuity at x is equal to 1. So now x is equal to 1 is less than or equal to 1. Equal to 1, no. So f of x, what we have to consider for this? F of x is equal to x we have to consider. Why? Because x is equal to 1. 1 is equal to 1 or less than 1. Less than we cannot consider, but equal to 1 is there. So f of x is x. So x is equal to 1, substitute f of 1 value. Now f of 1 is equal to 1. Keep that equation number 1. So now find out limit x tends to 1 f of x. So which is equal to limit x tends to 1 x. F of x is x. No, x is equal to 1, substitute. Equation number 2. From 1 and 2 we conclude that from 1 and 2 we have limit x tends to 1 f of x is equal to f of 1. Therefore, f is continuous. F is continuous at x is equal to 1. Now checking the continuity at x is equal to 2. Checking the continuity at x is equal to 2. X is equal to 2 means it is greater than 1 only, no? So f of x is equal to 2 means 2 is greater than 1. So function f of x is equal to 5 will come. So f of 2 is equal to 5. So dear students, here you remember x is left and right hand limit we can calculate. Here limit extends to 1 means here 1 plus 1 minus is there, no? How can I write like limit extends to? F is not continuous. Why? Because here limit extends to 1 plus f of x or HL value. Extends to 1 plus means x is greater than 1. That value is 5. Limit extends to 1 plus f of x value is 5. Right hand limit, this is limit extends to LHS value. Limit extends to 1 minus f of x. Extends to 1 means x is less than 1. That value is x. Limit extends to 1 minus x. Both values are not equal now. So therefore f of x is not continuous at x is equal to 1. Why? Because since LHL is not equal to RHL. So 1 is not equal to 5, dear students. I hope you understand. Now checking the continuity at x is equal to 2. F of 2 is equal to 5. Equation number 1. LHL, RHL, this is 1, this is 5. Checking the continuity at x is equal to 2, 2 is greater than 1. F of 2, how it comes? Limit extends to 2, f of x. X is equal to 2, f of x value is 5 now. Limit extends to 2, 5. So from 1 and 2, why sir you are particularly for this we are taking like this means it is based on the condition, dear students. But here 2 plus 2 minus is not given means we can go like this only. So from 1 and 2 we conclude that limit extends to 2 f of x is equal to f of 2. Therefore f is continuous at x is equal to 2. At x is equal to 1 not continuous. At x is equal to, but this is not the case. Whenever you are considering LHS and RHS in particular case of 1, so f of x is not continuous at x is equal to 1. Of course these two are equal, but limit extends to 1 f of x value. Two limits we are existing, 1 plus 1 minus. So in that case it will be rejected. Now come to question number 2. In question number 2, they are asking to verify at x is equal to 2. Left and right is there. So given function it is f of 2 calculator. Function value at x is equal to 2. 2 into x is equal to x is less than or equal to 2 is there, no? So at x is equal to 2 function value. F of 2 means 2 into 2 plus 3. 4 plus 3 which is equal to 7. Equation number 1, dear students. Next, left hand limit. Limit extends to 2 minus f of x. Extends to 2 minus means x is less than 2. Again the same function you have to consider. Limit extends to 2 minus 2x plus 3. X is equal to 2, substitute 2 into 2 plus 3 which is equal to 4 plus 3 which is equal to 7. Equation number 2. Limit extends to 2 plus f of x. Limit extends to 2 plus. Extends to 2 plus means x is greater than 2. We have to consider this function. 2x minus 3. So 2 into 2 minus 3. 4 minus 3, which is equal to 1. From 1, 2 and 3, we conclude f of 2 is equal to limit extends to 2 minus f of x, but should not be equal to limit extends to 2 plus f of x. So whenever among these three, any one of them is not equal, f of x is not continuous. Not continuous at x is equal to 2, or discontinuous at x is equal to 2, dear students. So let us discuss the next question. Here two possibilities, we are going to do that. Yeah, hi dear student Asrita Kil. Thank you for joining. Here at x is equal to minus 3, at x is equal to 3, both we will do it. At x is equal to minus 3, x is less than or equal to minus 3 means this function you have to consider. So f of minus 3 is equal to mod minus 3 plus 3. So modulus of any number is always positive. 3 plus 3, 6. Equation number 1. Next, limit extends to minus 3 minus. Extends to 3 minus 3 minus means x is less than minus 3. This function you have to consider. So which is equal to limit extends to minus 3 minus mod x plus 3. So which is equal to mod minus 3 plus 3, which is equal to 3 plus 3, which is equal to 6. Equation number 2. Limit extends to minus 3 plus f of x. So limit extends to minus 3 plus. Extends to minus 3 plus means minus 3 is less than x means x is greater than minus 3. So minus 2x you have to consider. So x is equal to minus 3, substitute minus 2 into minus 3, which is equal to 6. So f of x is continuous at x is equal to minus 3. Since f of minus 3 is equal to limit extends to minus 3 minus f of x, this is equal to limit extends to minus 3 plus f of x. So all values are equal now, dear students. So now come to the question number, same question, but we are checking the continuity at x is equal to plus 3. At x is equal to 3, we are checking that. So f of 3 is equal to x is greater than or equal to 3 means this function you have to consider. 6 into 3 plus 2, 18 plus 2 is 20, equation number 1. Next, limit extends to 3 plus f of x. X is greater than 3. X is greater than 3 means this function you have to consider. Limit extends to 3 plus 6x plus 2. X is equal to 3, substitute 18 plus 2, 20. Equation number 2. Limit extends to 3 minus f of x. Limit extends to 3 minus, extends to 3 minus x is less than 3. This function you have to consider. Minus 2x, which is equal to minus 2 into 3. That is equal to minus 6. Equation number 3. From 1 and 2 and 3, from 1, 2 and 3, f of 3 is equal to limit extends to 3 plus f of x, but not equal to limit extends to 3 minus f of x. Therefore, f of x is discontinuous or not continuous. Not continuous at x is equal to 3. But at x is equal to minus 3, it will be continuous, dear students. But discontinuous at x is equal to 3. Okay, dear students, we'll move to question number 4. Questions all about continuity. So we need to write that down. Are you able to see, dear students, the question? Question number 4. F of x is equal to mod x by x if x is not equal to 0, 0 if x is equal to 0. Next, question number 5. F of x is equal to x by mod x if x is less than 0, minus 1 if x is greater than or equal to 0. Later we will write it other. See, how we are going to do is, at x is equal to 0, they are asking to find. At x is equal to 0, f of 0 is equal to x is equal to 0, substitute 0 will come. Equation number 1. Next, LHL at x is equal to 0. What is the meaning of LHL at x is equal to 0? Limit x tends to 0 minus f of x. X tends to 0 minus means x is less than 0. So when x is less than 0, mod x value will become, so generally mod x by x now. So limit x tends to 0 minus, mod x will become minus x by x, which is equal to minus 1. Keep it as equation number 2. RHL at x is equal to 0, limit x tends to 0 minus f of x equal to limit x tends to 0 plus, sorry here plus 0 plus means again the same function, but the change is x tends to 0 plus is x is greater than 0. When x is greater than 0, mod x will become limit x tends to 0 plus x by x, which is equal to 1. Equation number 3. From 1 and 2 and 3, from 1, 2 and 3, we conclude that f of 0 is not equal to limit extends to 0 minus f of x, which is also not equal to limit extends to 0 plus f of x. So from this, f of x is not continuous or discontinuous. F of x is not continuous at x is equal to 0. Okay, dear students. This is similar way we can do that. No points of discontinuity. The similar way we can at x is equal to 0, at x is equal to 0, here 0 greater than 0 less than 0 and equal to 0 is given now. At x is equal to 0, f of 0 is equal to x is equal to 0, substitute this value is equal to minus 1. Keep it as equation number 1. Next, LHL at x is equal to 0. Limit x tends to 0 minus f of x. X tends to 0 minus means x is less than minus 1. Sorry, minus x. Limit x tends to 0 minus x is less than 0. Clearly, x by mod x. Limit x tends to 0 minus x by minus x, which is equal to minus 1. Keep it as equation number 2. Or HL at x is equal to 0. Limit x tends to 0 plus f of x. Limit x tends to 0 plus x by mod x. So limit x tends to 0 plus x by mod x will become x. Why? Because x is greater than mod x. But here x is greater than 0, f of x value is given as minus 1. Since x is greater than 0, f of 0 value is given as minus 1. Therefore, this is contradiction. Here we are getting 1, here it is given as minus 1. Both are contradiction. So, no points of discontinuity. Therefore, f of 0 is equal to limit x tends to 0 minus f of x, but not equal to even x is greater than 0 also. We are getting x is greater than or 0. Greater than also we are getting the same minus 1 and less than so. X tends to 0 plus. Generally mod x value is plus x, so it will become as 1, no? So limit x tends to 0 plus f of x. We cannot say that at exactly what point it is discontinuous. Therefore, f of x from 1 and 2 and 3, from 1, 2 and 3, f of x has no points of discontinuous, no points of discontinuous continuity, otherwise discontinuity. Why? Because if you observe carefully, x tends to 0 plus means x is greater than 0. Even that time also, no need of taking this value directly, no need of taking x by modulus of x. Instead of this, you can take as minus 1 directly. So this one is minus 1, this one is minus 1, this one is minus 1. So obviously what will come? No points of discontinuity means discontinuous. So f of x is continuous at x is equal to 0. So we will go for question number 6. In question number 6, so what is the function? F of x is equal to x plus 1, x square plus 1 if x is greater than or equal to 1, if x is less than 1. So first we have to verify at x is equal to 1. So at x is equal to 1, function value f of 1 is equal to x is equal to 1, substitute dear students, 1 plus 1 which is equal to 2. Next, limit x tends to 1 plus f of x, that means x is greater than 1. Limit x tends to 1 plus, x tends to 1 plus means x is greater than 1, x is greater than 1 also same function we have to consider. So x is equal to 1, substitute 1 plus 1 which is equal to 2. Next, limit x tends to 1 minus f of x. So x tends to 1 minus means x is less than 1. When x is less than 1, function value is x square plus 1. X is equal to 1, substitute 1 square plus 1. 1 plus 1 which is equal to 2. Equation number 3. So from 1 and 2 and 3, from 1, 2 and 3, we conclude that f of x is continuous at x is equal to 1. That means no points of discontinuous. There is no chance for discontinuous. Okay, dear students, I hope you understand. We'll move on to question number 7. What is that question number 7? F of x has the function values x cube minus 3 if x is less than or equal to 2, x square plus 1 if x is greater than 2. See what we have to do first at x is equal to 2. At x is equal to 2, function value f of 2 is equal to x is less than or equal to 2 means this function only you can consider 2 cube minus 3. So 8 minus 3 which is equal to 5. Keep it as equation number 1. Next, limit x tends to 2 plus f of x which is equal to limit x tends to 2 plus means x is greater than 2. This function you have to consider x square plus 1. So 2 square plus 1 which is equal to 4 plus 1 which is equal to 5. Keep it as equation number 2. Next, limit x tends to 2 minus f of x. Limit x tends to 2 minus f of x means x tends to 2 minus x is less than 2. Again, the same function you have to consider x cube minus 3. X equal to 2, substitute 2 cube minus 3. So 8 minus 3 which is equal to 5. So therefore, f of x is continuous. We can say that. Continuous at x is equal to 2. Since from 1, 2 and 3 equations, we conclude that it is continuous. Okay, dear students. Let us discuss the question number 10. Sorry, 8. In question number 8, the function f of x is equal to x power 10 minus 1 if x is less than or equal to 1. X square if x is greater than 1. So here we need to verify at x is equal to 1. So at x is equal to 1, f of 1 is equal to, x is equal to 1 means this function, dear students, 1 power 10 minus 1, 1 minus 1, which is equal to 0. Keep it as equation number 1. Later, limit x tends to 1 minus f of x, that means left hand limit. Limit x tends to 1 minus, x tends to 1 minus x is less than 1. Again, the same function you have to consider. So x is equal to 1, substitute 1 power 10 minus 1, 1 minus 1, which is equal to 0. Similarly, limit x tends to 1 plus f of x, x is greater than 1. Limit x tends to 1 plus x is greater than 1. The function is x square, x is equal to 1 square. Question number 3. So 8, 1 at x is equal to 1, no? From 1 and 2 and 3, from 1 is CV Subramaniam. Yeah, tell me, dear students. From 1, 2 and 3, we conclude that f of x is not continuous, discontinuous, at x is equal to 1. Since f of 1 is equal to limit x tends to 1 minus f of x, but should not be equal to limit x tends to 1 plus f of x. Okay, dear students, this is the reason the given function is not continuous at x is equal to 1. Now we will move to question number 9. This question number 9. In question number 9, is the function f of x, is the function f of x defined by f of x is equal to x plus 5 if x is less than or equal to 1, x minus 5 if x is greater than 1, a continuous function, question mark, dear students. Is this function is continuous or not? We need to verify. So obviously what we have to do at x is equal to 1, we need to verify at x is equal to 1, the function value f of 1 is equal to, less than or equal to means x is equal to 1 also substitute in this. So 1 plus 5, which is equal to 6. Keep it as equation number 1, dear students. Limit x tends to, first left hand limit at x is equal, limit x tends to 1 minus f of x. X tends to 1 minus meaning is x is less than 1. Again you have to consider this function. Limit x tends to 1 minus f of x is x plus 5. X is equal to 1, substitute 1 plus 5, which is equal to 6. Next, limit x tends to 1 plus f of x, right hand limit. Limit x tends to 1 plus, x tends to 1 plus means x is greater than 1. This function is x minus 5. So 1 minus 5, which is equal to minus 4, equation number 3. From 1 and 2 and 3, we conclude from 1, 2 and 3, we have f of 1 is equal to limit x tends to 1 minus f of x, but should not be equal to limit extends to 1 plus f of x. Therefore, f of x is not continuous. Not continuous at x is equal to 1 or discontinuous. Both the meaning is same, dear students. So let us move question number 10. Discuss the continuity of the function. Here the heading is discuss the continuity. Discuss the continuity of the function f. Of the function f, where f is defined. Where f is defined by. So question number 10 is f of x is equal to three if 0 is less than or equal to 1, 4 if 1 is less than x is less than 3, 5 if 3 is less than or equal to x is less than or equal to 10. So, from this data, dear students, so how we are going to give the answer for this? At what point we need to verify the function is continuous or not? Till 14 questions we will discuss in this class. See, by observing at x is equal to 1 we will verify, at x is equal to 3 also verify. At 0 and 10 we cannot verify. Same numbers are not there. So first, at x is equal to 1 I am going to take. At x is equal to 1, f of 1 value, x is equal to 1 means this function only you can take it. This is 3. Next, limit x tends to 1 minus f of x. X tends to 1 minus means left hand limit at x is equal to 1. So x is less than 1. X is less than 1 means again this same function. F of x value is 3 only now. So equation number 2. Next, right hand limit. Limit x tends to 1 plus f of x. X tends to 1 plus means 1 is less than x means x is greater than 1 only now. So this value is 4, equation number 3. So from 1 and 2 and 3, from 1, 2 and 3, f of 1 is equal to limit x tends to 1 minus f of x, but should not be equal to limit x tends to 1 plus f of x. So among these three, any one of them is not equal, then the function is not continuous. Therefore, f of x is not continuous or it is continuous. At x is equal to 1. Next, at x is equal to 3 also we can verify. At x is equal to 3, x is 3 is less than or equal to x means at f of x, f of 3 is equal to 5. Equation number 1. Limit x tends to 3 minus f of x. So left hand limit at x is equal to 3. The meaning is limit x tends to 3 minus x is less than 3 means the function value is what? 4. Equation number 2. Limit x tends to 3 plus f of x. So limit x tends to 3 plus. X tends to 3 plus means x is greater than 3. 3 is less than x means x is greater than 3. The value is 5 only now. So the function value is 5, equation number 3. So f of 3 is equal to, f of 3 is not equal to limit x tends to 3 minus f of x is not equal to limit x tends to 3 plus f of x. These two are not equal, but this value is equal to this one. Anyway, these two are not equal, but these two are equal, dear students. F of 3 and that time what we have to write is f of 3 is equal to limit extends to 3 plus f of x, but not equal to limit extends to 3 minus f of x. Instead of this step, this is a good information. Therefore, from 1 and 2 and 3, 1, 2 and 3, we conclude f of x is not continuous, not continuous at x is equal to 3, dear students. So clearly you observe that. So based on the question number 10, f is not continuous at x is equal to 1 and 3. Similarly, question number 11, 0 we can, 1 also we can. We need to verify. 12th also, at 1 and minus 1 we need to verify. So question number 11, dear students. So question number 11, the function is f of x is equal to 2x if x is less than 0, 0 if 0 is less than or equal to x is less than or equal to 1, 4x if x is greater than 1. Okay, dear students. They did not mention at where the function is defined, we can verify the continuity. See, clearly x is less than 0, 0 is less than x means 0 is less than or equal to x means x is greater than or equal to 0. Here also, two cases we will consider like this. At x is equal to 0, f of 0 is equal to 0. Limit x tends to 0 minus f of x. X tends to 0 minus x is less than 0. 0 is less than x is. So limit x tends to 0 minus 2 into x. X is equal to 0, substitute 2 into 0. Limit x tends to 0 plus f of x. Limit x tends to 0 plus, x tends to 0 plus means 0 is less than x means x is greater than 0 only. No? So what is the function we have? 0. So all are getting 0 now. So therefore from 1, 2 and 3, f of 0 is equal to limit x tends to 0 minus f of x is also equal to limit x tends to 0 plus f of x. Therefore f of x is continuous at x is equal to 0. I hope you understand it, students. Next one also, no? At x is equal to 1, f of 1 equal to, at x is less than or equal to 1, this value is 0. Keep it as equation number 1. So limit x tends to 1 minus f of x. X tends to 1 minus means x is less than 1. Again x is less than 1 means same function. Limit x tends to 1 minus f of x value is 0. So x is equal to 1, substitute in this, 0 will come. Equation number 2. Limit x tends to 1 plus f of x. X is greater than 1. So limit x tends to 1 plus f of x. X tends to 1 plus means x is greater than 1. The function value is 4x. X is equal to 1, substitute 4 into 1 which is equal to 4. So from 1 and 2, from 1, 2 and 3, limit f of 1 is equal to limit extends to 1 minus f of x, but not equal to limit extends to 1 plus f of x. So f of x is not continuous, at x is equal to 1, or discontinuous. So the function is at x is equal to 0. At x is equal to 0, f of x is continuous. So question number 11, we conclude at x is equal to 1 is the only point of discontinuity. Yes, at x is equal to 1 it is discontinuous. So now we will move to question number 12. In question number 12, the similar way we need to verify. F of x is equal to minus 2 if x is less than or equal to 1. X is less than or equal to minus 1. 2x if minus 1 is less than x is less than 3. Sorry. Less than 1. Next 2 if x is greater than 1. At minus 1 and plus 1 we will calculate. So at x is equal to first minus 1. So f of minus 1 is equal to x is equal to minus 1, substitute in this, it will be minus 2. Equation number 1. Limit extends to minus 1 minus f of x. Limit extends to minus 1 minus x is extends to minus 1 minus means x is less than minus 1. X is less than minus 1, the function value is minus 2. So which is equal to minus 2. Keep that equation number 2. Next, limit extends to minus 1 plus f of x. So which is equal to limit extends to minus 1 plus. Minus 1 plus means minus 1 is less than x means x is greater than 1 more. So this function you have to consider. So x is equal to minus 1, substitute in this. 2 into minus 1 which is equal to minus 2. So from 1 and 2 and 3 equations we conclude from 1, 2 and 3 f of minus 1 is equal to limit extends to 1 minus f of x is also equal to limit extends to minus 1 plus f of x. So f of x is continuous at x is equal to minus 1. Now we will verify at x is equal to 0. Now the function at x is equal to 1, at x is equal to 1, equal to 1, f of 1 is equal to 2 into 1 which is equal to 2. Equation number 1. Limit extends to 1 minus f of x. 1 minus means x is less than 1. When x is less than 1, again the same function. limit x tends to 1 minus 2x. So 2 into 1 substitute, which is equal to 2, equation number 2. Limit x tends to 1 plus f of x. Limit x tends to 1 plus, x tends to 1 plus means x is greater than 2. So the function value is 2. So 2. So by observing the data, f of x, question number 12, continuous at x is equal to 1, not only at 1 but also minus 1. From 1, 2 and 3, f of 1 is equal to limit x tends to 1 minus f of x is equal to limit x tends to 1 plus f of x. Therefore, f of x is continuous at x is equal to 1. So now question number 13 and 14. But question number 13 and 14, these type of questions, they may chances to ask in either in competitive exams like MSET, JEE Mains, or any other competitive exams like BITSAT, AEEE, like NDA. Question number 13. Find the relation between A and B so that the function f of x f defined by f of x is equal to ax plus 1 if x is less than or equal to 3, bx plus 3 if x is greater than 3, is continuous at x is equal to. So dear students, we need to prove f of x is continuous means left hand limit, right hand limit, all we can substitute. So first what we have to write, f of x is continuous at x is equal to 3, that is f of 3 is equal to limit x tends to 3 minus f of x, that is equal to limit x tends to 3 plus f of x. That means f of 3 means function value. Limit x tends to 3 minus f of x means the left hand limit at x is equal to 3. Limit x tends to 3 plus f of x means right hand limit at x is equal to 3. So at x is equal to 3 function value. So at x is equal to 3 function value, wherever x is there, replace with 3. So a into 3 plus 1 is equal to x tends to 3 minus means x is less than 3. Again, the same function, we have to write it. Limit x tends to 3 minus ax plus 1, which is equal to limit x tends to 3 plus 3 plus means x is greater than 3. The function is what? Bx plus 3. So 3a plus 1 is equal to x is equal to 3, substitute 3a plus 1 is equal to x is equal to 3, substitute 3b plus 3. So they are asking to find the relation between them. If we equate these two, there is no use. If we equate these two, 3a plus 1 equal to 3b plus 3. So 3b bring this side. 3a minus 3b is equal to 3 minus 1. So 3a minus 3b is equal to 2. This is the relation between a and b if the function is continuous at x is equal to 3. But sometimes they won't give like this. They will make subject as a or b. So 3a is equal to 2 plus 3b. So a is equal to dividing throughout this by 3. So 3b by 3 means b plus 2 by 3. Okay, dear students. Even this is also in terms of b also, if you write, that is also correct answer. Next question number 14. For what value of lambda, for what value of lambda is the function defined by f of x is equal to lambda into x square minus 2x if x is less than or equal to 0, 4x plus 1 if x is greater than 0. So continuous at x is equal to 0, continuous at x is equal to 0, question mark. What about continuity at x is equal to 1, question mark. First, f of x is continuous at x is equal to 0, question mark. For what values of lambda? If the question is like this, we will see that, we will verify that. First, case 1, f of x is continuous if we take f of x is, for what values of lambda means is function defined by and continuous at x equal to 0, question mark. F of x is continuous at x is equal to 0, that is f of 0 equal to left limit, that means limit x tends to 0 minus f of x, that is equal to limit x tends to 0 plus f of x. F of 0 at x is equal to 0, x is equal to 0, substitute lambda into 0. Limit x tends to 0 minus means x is less than 0. Again the same function. Limit x tends to 0 minus lambda into x square minus 2x. Limit x tends to 0 plus f of x. x tends to 0 plus means this function 4x plus 1. So 0, x equal to 0 substitute lambda into 0, even here also 0, x equal to 0 substitute 1. So there is no lambda. Therefore, what you can give the conclusion for this question number 1? For no value of lambda, 0, 0 here 1 means it is not. For no value of lambda, f of x is continuous at x is equal to 0. Now we will move to question number, in this same question, second question. In the second question, f of x is continuous at x is equal to 1. That is, f of 1 is equal to limit x tends to 1 minus f of x is equal to limit x tends to 1 plus f of x. F of 1 means 1 is x is greater than 0. So here it will take. So this is equation number 1, dear students. F of 1 means x is equal to 1, which is greater than 0, no? So x is greater than 0 means the function you have to consider 4x. 4 into 1 plus 1, which is equal to 5. Next, limit x tends to 1 minus f of x. X tends to 1 minus means x is less than 1. X is less than 1 equal to 0 only it comes. So lambda into x square minus 2x. Limit x tends to 1 minus. So lambda into 1 minus 2, that is equal to minus lambda. Next, limit x tends to 1 plus f of x. So limit x tends to 1 plus x tends to 1 plus x means x is greater than 1. X is greater than 1 means the value greater than 0 means 1, 2, 3, any value it comes. So greater than 0 means this x is greater than 1 means you can take this function also. For x plus 1, x is equal to 1 substitute, 4 plus 1 is equal to 5. So these three values from 1, 5 equal to minus lambda equal to 5. So that implies lambda equal to minus 5. For any value of lambda will come, lambda is not only minus 5 but also for any value of lambda, for this particularly lambda is equal to minus 5, and for any value of lambda, f of x is continuous at x is equal to 1. Here, dear students, one important thing you remember. Here x is equal to 1 greater than 0, no? So, but we have the question here in this. X is greater than 1 means here x is greater than 0 means 1, 2, 3 like this and so on will come. So, for taking the values of 1, 2, 3, these lambda values will come, dear students. You have to observe that. These 1, 2, 3 values based on the taking x is equal to 1, x is equal to 2, 3 and so on, these lambda values will change. That is why for any value of lambda, f of x is continuous at x is equal to 1. Hence, the solution. This is the way we can give it to your students. I am going to end the session. Thank you for your support. Jai Hind. Math Solutions by Pani. Those who are watching first time, please like and share. Thank you, all of you.